Now, in the last class, we were talking about binary search. And when we talk about binary search, if you look at the data that you have, it is already in sorted order. So you have something at index 0 and maybe at index 11. And there are some numbers. So maybe this is some array, let's say. Now, need not be same integers, but as long as you are having those in ascending order, it is going to work. And let's say if we are searching for some number 50, generally what we do is we find the mid from the list. So, and we check if the number to check is same as mid. Now, if it is, we will say that the number is found. If not, we are going to check if this mid is less than or greater than the number to be searched. So here mid is less than 50 because 11 is less than 50. So the very first number is the middle number. Again, if the index is odd, we are going to find maybe if you're getting 4.5, then you are going to search the fourth index and then try to find out. Now, if it is less, then it means it cannot be in the left-hand side of the list. So automatically this part of the list we are going to get rid of, and we are going to find the number on the right-hand side of the list. So in a way, we are going to call the binary search again on the sublist. And in this time, if we say, what is my middle value, that is 50, and that was the key we were looking for, so it is found. If the value, let's say if we are searching for 3, now the value we were looking is less than the key. So now we know that it will appear on the left-hand side sublist. So in that case, the right-hand side sublist we are going to get rid of. So at every iteration, our search space gets reduced by half. So if you look at the way they have implemented and made it a recursive case approach. So if key is less than middle element, we are going to search in the first half of the array. If key is equal to middle element, we are going to say it is found. If key is greater than middle element, we are going to search in the right or second half of the array. So in implementation, we are going to say pass the integer list and the key that we want to find to that method. And our first index is index 0 and second index or high we are calling is list.length -1. Now again, the underlying assumption is that the list we are getting is already sorted. So we are not going to sort it, it is already sorted. We are going to just search. So now we have the list, the key, low and high. Now every time we will see how the function calls itself. So recursive binary search, we have key. If the low is greater than high at some point, meaning that we do not have any more elements to be searched, then we are going to return low is equal to 1. Otherwise, so if the list has been exhausted without match, so we found everywhere and we didn't get that element. So at that time, we are going to return that the element is not found. Otherwise, we are going to find the middle index by saying average of low plus high divided by 2. If the key is less than middle, we are going to call the recursive binary search on list, the same list, then key, low and middle -1. If key is middle, then we are going to return that key is found. Otherwise, that is a condition when key is greater than the middle value. We are going to call recursive binary search on the list, where again we are passing key And now we are going to look it in the remaining half, which is middle plus 1 to high. So in that range, we are going to look. So this Tower of Hanoi example we saw. So I think this is also implementation of recursive binary search. We can go through. I think it will also have same thing. So again, I think it's the same code that we just saw. And in the main function, they have given some list of numbers which are in ascending order 1, 2, 3, 4, 5, 6, 7, 8 numbers. And we want to print or we want to find some key. So what is the key? Key 7. So the first time key is 7. Second time key is 0. Now 7 is in the list, so we should get that it is there. And 7 is not in the list. Sorry, 0 is not in the list. So if we run this program, then we should get the output accordingly that 2. So this is the index given. 7 is at index 2, 0, 1, 2. And if it gives -1, it means it is not there. So I think that is done by minus low -1. So that is returning, low is 0. So it is returning -1 value. So whenever we get a -1 value, it means the value is not there. So for 0, it is giving -1. For 7, it is giving the index. So again, you will see that the binary search inside the same function, it is calling itself. So here, if you look at the binary search, it is calling once for the first half, otherwise for the second half. So that's how the recursive call is. And there are a few more examples also, but I think I just covered the main palindrome we saw in the last class. So we'll start the collections. So this is chapter 20, and with this chapter, we are really discussing different data structures. And looking at right now, we are using the pre-implemented version of it. So we are not really implementing our own. So if you take the list or stack or queue or priority queue, those are already there in the Java util library, and we are just going to use those. But before using that, we need to know the functionality. So what different things these data structures can do. So even if we implement our own, the thing is they have implemented it in a very optimized way. So we can always get better results with the pre-implemented one. Now, sometimes when we want to create our own data structure, let's say student name and ID, and we want to sort based on ID. In that case, we might not be able to use the already existing ones. So we will create our own. So if you look at the collection interface so this is kind of a summary. So what things we are going to cover. So whenever we are talking about all these things, lists, stack, queues, priority queues, they are data structure. And basically the way we are learning data structures in computer science is in a very abstract manner. Means we are not going to look how they have implemented or how they have done implementation, but we are only going to look at what data we can store and what operations we can we can use. So that is also called as ADT, abstract data type. So we are looking at only from the point of what data we can store or how the data I can access, and then what different operations we can perform on each of these. Now, pretty much for every, when I say data structure, we expect few things. So if I have a data, what things I want from that data? Maybe if I want a data structure, I should be able to add data in that data structure. I should be able to remove data from that data structure, right? Then I should be able to search if a particular data is there or not there. So search operation is important. So add, remove, search. What else we should be able to do in this case? Maybe we want to add at a particular position. So add at a particular position, or we want to remove from a particular position. Remove data at index 10, remove data from index 3. Then we can search, we can remove, we can check if the data structure has some values in it or it is empty and so on. So the main functions are adding, removing and searching. So every data structure that we want to implement, we should be able to add, remove, search and access. So these four are basic operations we should be able to do with all data structures. Now, a collection is a container object that holds different objects. So all these objects, list, linked list, array list, queue, all are in the collection framework, and we will see how they are divided. So it is one for storing, and it is also storing key value pairs, which we call as map. And when we are just storing a data structure simply in a as a collection of data, might be a set, might be a array. So or array list. In that case, we are going to call it as a collection. Now, this is kind of the interface implementation. So those interfaces are already there. So when we use, we might say that we implement this or we extend this or we can directly create. And these are the, so whatever you see are in italics, those are interfaces or abstract classes. So these are this whole line interfaces. So we have collection interface, in that we have set, list, queue, and sorted list and deck. Now we know that if it is interface, then the methods are not implemented. So depending upon what type we are creating or what concrete class we create, in that the methods will be implemented. So the collection interface is also implemented by these abstract classes. So there is a dotted line which separates interfaces from abstract classes. And the abstract classes are abstract set, abstract collection, abstract list, abstract sequential list, and abstract queue. So now these abstract classes are implementing these interfaces, and so they will carry all the methods. But again, the method implementation is not there. And now when we create the actual concrete classes, so now these are not italic. You can see the tree set, hash set, linked hash set, vector, stack, array list, linked list, priority queue. So those are now all the classes which are there, and we can create the object of this class to use in our program. So directly when we say linked list L, and we need to give what data type that linked list need to store, and that it just creates the linked list. Then it has all the capability that a linked list needs. So we should be able to add, delete, add at index, delete from index, then print all the values and so on. So pretty much that functionality is similar into all this data structure. So this is another, maybe the UML diagram is too small. Open it here. So this is the collection interface. So these are things. So it has one, again, iterator, which will return one iterator element. So if we create iterator now, that iterator will allow us to access all the elements from that particular whichever object we create using this interface. And these are the basic methods. Now, again, these methods are not implemented here because unless we know what the data type is, if it is stack, this method will look different than if it is queue or priority. But these are the basic methods. Add, so any element we can add. and it will create true if that element gets added correctly, false if it doesn't get add all. So we can also have, it also has a capability, let's say we are creating a list of elements. So we have 4 elements and then another list has 4 elements. Now, if we want to add the second list fully in the first list, then we can do that by using add all. So take that second list and add all the 4 elements in the first list. So directly now we will have 8 elements. Then clear, this is kind of a delete all. So it will delete all the elements from that data structure. Contains, it's kind of searching. So the I wrote we need to search. So this is called as contains method. So contains and then you can give value. So if it is a let's say string object or a string list and it has certain cities we have added, let's say Dallas, Chicago, New York, and then if we have to find, we will give this method. If list dot contains Dallas, and if it contains, we are going to get a value true. If it doesn't, it will return false value. Then contains all. So here we are going to pass maybe list and check if all the values in this list are also there in this list. Again, if it is true, it will, if it contains, it will return true. If not, it will return false. Then equals, it will return true if it is equal to another object that we are comparing. If not, it will return false. So those are basic methods. And then hash code for this collection. So internally, whenever typically we are using hash maps or keys, internally it might assign some hash code to it. So depending upon which data type we are calling, and then it checks that if the hash code is already generated for that particular object, then this is a same object and so on. And then we cannot add that object. Then is empty, we saw if you don't have anything in that data structure, then this will be true. If you have at least one element, then this will be false. Then remove, again, this is similar to delete. It will delete whatever object you pass from that list. Remove all. So if you want to give a sublist and you want to remove 3 cities at the same time, it can do by saying remove all and pass one things you want to remove. Then retain all. Then in this case, it's the like kind of a opposite of remove all. So here you are going to retain those elements, even if you are going to later on adding for the same key, you are going to not wipe out the original data. And then size, it will tell you how many elements are there in that data structure. To array, if you want to convert it into array form, and this is to array if you want to convert it, I believe in the generic type data. So those are all possible methods. Again, depending upon different data structure. Now Q will not have all these methods because in Q we have fixed way of entering and removing data. Similarly, stack might not implement all these, but these are kind of basic which these data structures might have. Has next, if you want to iterate through the value, as long as you have next value, we are going to read and it will return true if it has some more values to be read. Next, it will give us next element in the in that list, and remove, it is going to remove the last element. So these are kind of a basic UML diagram for collection, and they have given a good so here is a simple example collection, and they have implemented all the methods that we saw. So not all, but the mostly used methods. So you will see that they have used array list. Array list was array list there. So array list was here. We saw that this is a concrete class. So now you can create all the concrete classes. You can create your own objects. So they created object of an array list, and that type of here we can give any primitive data type. So if you want to create array of string, you will write string. If array of integer, you will write integer. Array of double, you can write double, and create array list of that type. So I think few classes ago we did see one example of array list. So here it is similar to that, and they named it as a collection one, which is a new array list. Now, once you created an array list, now it has all the possible functions that an array list has. So basically all the function declarations were there in the interface, and now depending upon the array list implementations will be. So the dot add method, it just adds that data type value directly. So if it would be integer, we can add integer values. Now, since it is string, we can add different strings. So they're adding 4 different cities in the collection. So now it will have 4 cities in the collection one. If you say we want to print, it should print all the 4 cities. Now, if you want to check is Dallas in that collection, we want to use the contains method. So collection dot contains, and then you pass whichever key is there. And if it is true, it will return true. If not, it will return false. Then collection dot remove. Now it will remove that value Dallas from the list. Now they are also printing the collection dot size. So how many elements are there now in the list? Now let's say we created another array list by name collection 2, and now it has 4 more cities added. So collection 2 add Seattle, Portland, Los Angeles, Atlanta. Now this is my second list, array list having 4 different values. Now if you want to print, it will print these 4 values when we do the system.out print. Now when we use C1, so here they have created C1 as collection1.clone, so that will exactly have all the elements of collection 1. Or C1 will be exactly same as collection 1, because collection1.clone, it will create exact copy of collection 1. Now, in that copy, if you say add all collection 2, it will also add whatever values you have created in that list collection 2. So now individually you don't have to give that I want to add Seattle, I want to add Portland, I want to add. So collection 2 has the 4 values, and you can directly add the whole list into another list. And now if you see print cities in collection 1 or collection 2, so in a way it is a union. So either as long as the city is either in C1 or collection 1 or collection 2, it is going to print. So it will, in the end, it is going to give you how many values now? So first we had 4, then we deleted, I think, Dallas. So we have 3 values and plus these 4 values. So now we have 7 values. And if you print that C1 list, it should print all the 7 cities. Those are there. Now, another thing we can do is if we want to use kind of an AND operation where we want to keep those cities which are there in both collection 1 and collection 2, then they are using the retain all. So you retain all the cities from collection 2 which are also in C. So here I don't, is there any common city? Okay, Atlanta is a common city. So now it should only print that city which is common to both collection 1 and collection 2. Again, C1 is a clone of collection 1, and then now instead of add all, we are saying retain all. So only retain those values which are also there in C1 and C2. And the third operation, they are doing something similar to a set difference. So if you have 2 sets and if you do A minus B, then in that case, you say C1, again, you are creating clone of collection 1, but this time you are going to remove all which are there in collection. So in this case, what is going to happen is if there are some cities which are common to both, then those are going to get removed from your answer. So now here it is going to print all the cities in collection 1 which are not there in collection. So the three operations, first is collection 1 union collection 2, second is collection 1 intersection collection 2, and third is collection 1 minus or set difference collection. So if you compile this, so let's see what are the, so first a list gets created with 4 values. Now next is Dallas in the collection, true, it returns true value. And then if you remember after this, they removed Dallas from that list. So now we have 3 cities in the collection now. And the list of collection 2 is Seattle, Portland, and these 4 cities. Now cities in collection 1 or 2. So we have all the cities who are either part of collection 1 or 2. So it is kind of adding both. Then cities in collection 1 and 2, it is only giving Atlanta. Cities in collection 1, but not in 2, it is giving New York and Madison. It is taking out the Atlanta. And Dallas we already removed. So kind of how different operations on the array list will work. Now each data structure has iterator, so which will help us to go through all the values. And sometimes they do create an object of that iterator, and then you use that object to pass through all the values in the iterator. So I think they have shown here few examples of iterator. So if you want to create, or if you want to go through, if you just say, or if you just print, like in this example, if you just say system.out.println and collection 1, it will also print all the cities. So basically it takes this collection as a list of values and it is going to give you all the values like in this case. So you don't really have to access it as per se, you can just print, that will also give you all values. But if you want to access, then we need to create an iterator object. So iterator collection, and we want to give on which data structure we want to iterate. So the name is collection.iterator. And now while iterating, we have to check, do we have next value in the list? So the has next, as long as we have next value, it will read, print, or do whatever. So here they want to take that next value and change it to uppercase. So change that value to uppercase and then print. So do we have second value in the list? Change it to uppercase. Third value, change it to uppercase. Fourth value, change it to uppercase. Now list is finished, and so on. So very simple program. Again, if you compile and run, so they do make use of this code. So you can create your own lists. You can maybe check some different functionalities here. So here you will see that these 4 cities we added. And now iterator goes through all those and it changes it from small case to capital. So it is in the same, it's in the same. Now the list interface. So we see that array list, linked list. So all are coming from the list element or list interface. And here again, uh, as we saw in the array, all the basic functionalities are there. So we can access it by index, we can add it by index, we can remove values by index, and so on. But when we say, so there are two types of lists we will use. One is array list and one is linked list. So if you say list is that we talked about interface, which has all the methods but not implemented, then this is the abstract class. And then from there, these are the concrete classes, linked list, array list, where we are actually going to implement and create. Then in Java 8, we also have for each method. So we can iterate through like a for loop. So when we are talking about list, again, it has this, it is coming from the collection interface and it has this functionality. We can add all we just saw. We can get a particular value at that particular index. So here we can pass the index value. So get to will give us the value at index 2. Then what is the last index of list iterator? Remove, set, sublist, so on. Now, it also provides some more functions. So it has previous, has next, next index, previous index. So we can go back and forth in the list. Now some differences between array list and linked list. So as name suggests, array list is using arrays and linked list is using linked list. Now when we say array, again we know that in memory there will be a block of values which are assigned. So, but that part is now get taken care by the data structure. So you are not saying that whenever we created the array list collection, we didn't say that we want to assign 10 values. So let's say internally first it assigns a string array of 10 values. Once you start filling up those values, it automatically will increase the index. Now, if you have to increase or if you want to insert a value, 11th value, then generally it will create an array of a bigger size. Generally, it is, I believe, n plus n by 2 plus 1 or something. So if you have original array of size 10, then next it will be become 10 plus 5 plus 6 1. So next array it will create 16 of 16 values that can hold 16 values, and whatever values you have in your previous array, those will be copied in the new array, and after copying it will still have 6 more values which you can fill. So internally in a very optimized way those things are happening. So we are not doing it. If we are implementing array, then if we are done inserting 10 values and 11th value we have to insert, then we have to go and change the array size. So the array, if we say int a of, so if you remember int a of is equal to maybe you assigned 10, and then in that case if we have to insert 11th, then we have to change this value to maybe 20 by on our own. Here internally that data structure is taking care of everything. Now again, if we are deleting something at index 2, if we are deleting this value, then all the remaining values should shift one place to the left. If we are implementing array, we have to do it on our own. In array list, the data structure is taking care of that. So if you delete this, then all the right-hand side values will be shifted one place left. And again, that is happening internal. So the difference, as we can say that when it is array list, the internal implementation is using arrays. When it is linked list, the internal implementation is using linked list. So the values are stored in the memory in with the help of linked list. And again, we can add, delete, we can grow. So the good part is generally by nature, linked list, it is very easy to dynamically grow and shrink. In array, we still have some limitation, meaning that if you want to keep doing it again and again, if you want to insert new values, then it is going to be overhead. But arrays are precisely very good when you're searching by giving a particular index. So if you want to search more than add and delete, then array is better. If you want to add and delete more, then linked list is better. Because in linked list, if you want to search the value at index 2, you always have to start from the first value and then follow the links, go to the second, go to the index 1, search, go to index 2, and then add, delete, or do something. So if you look at array list is more efficient in terms of if you want to search by given index or access by given index. So maybe this is, it should be like a comparison table. Maybe I will make next time we can compare side by side. So if you look at the array list implementation, you will see that it is coming from the collection interface, which is again using the list interface, and then this is our concrete class. So we can create the things we can use is we can create array list, we can create array list from the existing collection, or we can empty list with some capacity, or we can print to size. So if you have size 10, we can reduce it to 5. And if we have linked list, then these are some additional functionalities that we have. We can add first, add last, get first, get last, remove first. Get the first element of the list, get the last element of. Now, how can we get last element so quickly? Because the linked list that they are using here is actually a doubly linked list. So you can you also have always the pointer to the first element and also to the last element. So the implementation of java.util.linked list uses doubly linked list. So you can add to first, so new element gets added here, or new element can get added here because we have pointer as both head and tail. And then you can remove first, you can add first, add last. So here is one example of array list and linked list. You will see that most of the functionalities are same. So internally, although they are implemented using different ways, so either array and linked list, but you will see that most of the functionalities that they offer are same. So here we created now the array list of integers, and now we can add directly the numbers. Array list add 1, 2, 3, 1, 4. So it creates a list of 1, 2, 3, 1, 4. Now we want to add at index 0, we want to add 10. At index 3, we want to add 30, and then we want to print the list. Now, similarly, they are creating a linked list. Now here we are just for passing any object. So ideally it should take different. So here we are passing string. So at index 1, pass red, remove last, and then add green, and then display that linked list using iterator, and display that linked list in forward direction, display it in backward direction, again both using the iterator. So if you are going from first to last, you are going to check till it has next element, print. If you are printing from tail to first, you are going to go to the last. So go to the tail and then check, as long as you have previous elements, you print the list. So you are moving from index 1, 0 to size -1, and the second you are moving from size -1 to index 0. So let's see if you run this example. So you will see that 1, 2, 3, 1, 4 were initially added, then 10 added at index 10 added at index 0, 30 added at index 3. So 0, 1, 2, 3. Then display linked list backwards. So they have added, I think, yeah. So linked list object linked new linked list array list. So they created one with same list, and now they want they added at index 1 red, then remove last, add first. So green is added first, then red, 10 red. There is red added at index 1, remove last. So what was the last element? I think 4 got removed. And then displaying the list in head to end of the list and in this opposite direction, tail to head. So you can go through this. You can as well create the same thing. You can also create with linked list. So instead of array list, you can create new linked list, and you can pretty much do all the same operations using both array and linked list.